Hi class, today we're going over lesson 7.5, determining the outcomes of compound events. So for starters, let's talk about what a compound event is. So a compound event is an event that consists of two or more events. And I also wanted to remind you of your definition of an event. An event is a single outcome or a group of outcomes. So a compound, think compound means more than one, right? So this means our compound event is more than one event. So our key concept for today. A compound event is a combination of two or more events. We can organize this with an organized list, a table, or a tree diagram, and we will use these to represent the sample space of a compound event. The sample space for flipping two coins consists of four outcomes. Here, we could see that we could use a sample space and have it listed, right, where we got like heads, 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 tails, tails, head, and tails, tails. That will be one way to list our compound event. We could also use a table and box it out and have each outcome interact, see where the heads and heads meet. Then there's obviously two heads together and so on and so forth for all these. Or you can make it a tree diagram and you will show each outcome and each possibility for heads. So heads can have a heads paired with it or a tails paired with it, and tails can have a heads paired with it or a tails paired with it. All right, so let's get into our first example. So a new car can be purchased with four exterior colors: red, blue, yellow, and green. It can also have three interior colors: purple, orange, and rainbow. And we want to find out what are all the possible combinations for the car. So what this is asking us is what colors could we have on the outside as well as having the colors on the inside. So the way we're going to do this is we're just going to make a list of our sample space. So our first options for red, and I'll denote red as an R, blue as a B, yellow as a Y, green as a G, purple as a P, orange as an O, and rainbow as an R. Hopefully that's pretty straightforward. So now I want to list all my options for red. So red can be paired with a purple inside, red can be paired with a orange inside, and red can be paired with a rainbow inside. So those are all our options for red right here, right? Because we paired up every exterior color with every interior color. So now let's find all the options for blue. So blue can be paired up with a purple interior, blue can be paired up with an orange interior, or blue can be paired up with a red interior. So those are all our options for blue. Now we're going to go to yellow. So similar, yellow can be paired with all the same colors that everyone else can. And then so can green. So these are all of our possible outcomes for the pairings of the exterior of the car and the interior of the car. All right, so how many do we have? Well, we're literally just going to count them, right? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have 12 different combinations. We have 12 different combinations, right? So let's go back to what we did in this problem. So for starters, we were working with a compound event, right? The reason it's a compound event is because we have exterior colors and interior colors, right? Those are our two different probabilities, and we're working together. And then we found the compound event, the probability there, or all the possible combinations by just writing it out and making a list of them. All right, so let's go into question 2 here. So two friends go to an ice cream stand together. There are 3 different options for ice cream. You have vanilla, chocolate, and mint chocolate chip. You can get your ice cream in a cone or a cup, and we want to know all the combinations these friends can order. All right, so the way I'm going to do this is with a tree diagram. So I'm going to put my cup here and my cone here. Now I want to see all the different options that each of these have. So for cup, we could have a vanilla ice cream in a cup. We could have a chocolate, or we could have a mint chocolate chip. So those are 3 options for cup, right? Now for a cone, we have those same 3 options: vanilla, chocolate, and mint chocolate chip. So those are all of our outcomes here, right? So let's just go ahead and count them. Well, cup has 3, vanilla, chocolate, and mint chocolate chip. So does vanilla. It also has 3, vanilla, chocolate, and mint chocolate chip. So that means there are 6 combinations at this ice cream stand. All right, so let's go into our conclusion here. All right, so today we talked about compound events, right? And compound events are just two or more events together. We found those using organized lists, making a table, or making a tree diagram. We didn't get to making a table in this video, but we're sure to do one in class. Now for a second, I want to go back and look at these two questions we have here. So for our first question, we said that For our first question, we said that there's 12 different combinations, right? Well, let's think what we had here, right? So we had 4 exterior colors and 3 interior. So another way we could have found this is by doing 4 times 3, which would give us 12. So we combine all of our different outcomes and we get the same number there, 12. Also, in this next problem here, there's the different ice cream problems. So we have 3 different options for ice cream and 2 different options for what to put ice cream in. So we would have a total of 6 different options. So we found that just by multiplying these two together. So if you are struggling to make the table or something like that, that's another method you could use.